Hi, I'm Lynn Langett. Welcome to part 3 of my 5-part series on understanding Hadoop MapReduce fundamentals. As we just saw in the previous demo, there are ways to run MapReduce jobs, which can include running from the development environment as I showed there. Now, I introduced you to this idea of configuring the way the job executes through the job conf settings, and I included that directly in the MapReduce file, which is really a non-standard way of developing. I wanted to introduce you to the job conf settings. At the very least, of course, usually those 3 files, as I mentioned in the demo, the mapper, the reducer, and the job conf for the main method are separate. That's just a better design pattern, of course. Now, in addition to using job conf to tune or set the various knobs and configuration settings in the particular job, you can of course obviously tune on the cluster itself through configuration as well as through multiple chain jobs and many other ways, and we'll talk about that more in the optimization section. Now, in addition to just running your job from the development environment, I also showed earlier in the course running a job. Now, in that case it was a job executed via the HIVE abstraction layer using the GUI that's part of the Cloudera distribution called HIVE. Also, you can run through any provided GUI that the particular distribution includes. Coming up, I'll be showing you Microsoft's distribution and how to work with it and how to run jobs through the HD Insight console, which is a web interface. One tip that I'll give you when you're working with the various vendors' interface is to execute it in the environment that it's designed to work on. For example, I found that the HD Insight console works consistently using Internet Explorer but not using Google Chrome. You can, of course, also execute jobs directly from the Hadoop command line, and that frankly is the most common way I see people doing it in production environments. Of course, we're focused more on development, so I'm less concerned with the efficiency of production running jar files from either the Hadoop prompt, or as you'll see later in this course, you can actually run, depending on the operating system, with other utilities such as PowerShell for Windows Azure, for example. And the distribution I'm going to be showing is very new on the market. So new, in fact, at the time of this recording, the product is still a beta offering by private beta invite only. Then this is called HD Insight, which is Hadoop on Windows Azure. Now, a lot of people get very surprised by this offering because, of course, core Hadoop is known for running on the Linux operating system. So how did this come to pass? Well, Microsoft has been working on this for several years. In fact, a couple years ago when I was still an employee, I already started working with early betas. So I've been on the beta for this for quite some time. And what Microsoft has done is they've worked with the company Hortonworks, that includes a whole bunch of former Yahoo employees, which was one of the original heavy users of Hadoop. They formed their own company, Hortonworks, and they've worked in partnership with Microsoft Teams to do a port of the Hadoop binaries over to Windows Azure. Now, as part of the beta itself, there is 2 distributions that Microsoft is making available to beta invitees. One is to be part of the cloud hosted distribution, which the screenshot is showing here, and I'll be shortly demoing. The other is to download the bits locally onto a Windows machine and run Hadoop binaries on Windows. And the internal code name for that is called Isotope, and that's available through the web platform installer if you're interested in setting that up as well. So in the next couple demos, I'm going to show you first how to allocate an HD Insight Hadoop cluster on the Windows Azure cloud and just go through the portal steps to show you how that works. And then I'm going to show you how to run a MapReduce job via the HD Insight GUI portal, first in Java, and I will compare the Java that Microsoft uses with the Java that we just saw, and also then in JavaScript. So you can kind of get a sense of some of the different distributions. In this demonstration, I'm going to show you how to set up a Hadoop cluster on Windows Azure. So I've already signed in to my Azure account, and I have been granted access to the limited beta. At the time of this recording, which is April 2014, this service is still in an invite-only beta. So you'd have to send a request to Microsoft. They'd have to approve your particular account. So my account's been approved, so if I click New and I click Data Service, and then I go over to HD Insight, I have two different ways that I can work with this. I can do Quick Create, which I would put a cluster name, and then it would be .azure hdinsight.net, and then a cluster size. I could have from 4 to 32 data nodes, and then cluster information, and then a storage account. If I wanted to use Custom Create, that would take me through a wizard, which I will take you through partially in this video. So I'm going to call this one Lynn Pluralsight, and I'll say 4 data nodes, and here's the pricing information, and here's a check to show that that name is available and valid. And then I'm going to put in my username and password. Then I'm going to associate this with a storage key and account, a storage container and account. And I'll just take this one, I guess. And for the container, I will create a default container. Now you can see at the bottom that this is spinning up, and it's 18 minutes after the hour. So this is going to take a few minutes to spin up. So I'm going to go ahead and pause the video. So 14 minutes later, my cluster is up and running, and now we can access it. So you can see in the Azure portal it's running, and we can click Delete, Connect, or Manage. So if we click Manage, I have to log on with the username and password that I created during setup. And then I get a portal, a Metro style portal, where I can do some basic interaction with my Hadoop cluster. So this is comparable to what we saw earlier when we were running HIVE queries with Cloudera Beeswax. The difference, of course, is this distribution is running on the Windows Azure cloud. So you can see that here is the name of my cluster, linpluralsight.azure.hdinsight.net, and I have these buttons that allow me to interact with my implementation. So inside of here, I have the ability to create a MapReduce job. I have some samples. I have some documentation, downloads. I have an interactive console. I have the ability to RDP into my cluster. I have a job history, and I can monitor my cluster. So if I want to do a more detailed check, I can just click on Monitor. And you can see that because I haven't run anything yet for the last 30 minutes, I have no mappers, no reducers, nothing in the queue, no jobs. This is the health of my 4 worker nodes. Here's my name node and my job tracker. And it's just a snapshot, basically, of what's going on. Although you can connect to your Hadoop cluster using the portal page, as I just showed, if you go back to the main portal, you'll note that there's a Connect button at the bottom. So if I click on that, you can see that it's asking me to open an RDP connection. So I'm going to do that, and I'm going to click Connect, and then I'm going to say, yes, this computer is authorized, and click on my username, and put in my password. And you can see now I'm RDPing into my instance. And this is a standard Hadoop distribution, of course, with the difference being it runs on Windows Azure. Now, Microsoft worked with Hortonworks to write the port, and this is internally called Isotope. You can download, if you're approved for the beta, a version of this that can run on a local Windows instance as well. But of course, I'm running on Azure. So if I open this up, you can see that this is regular Hadoop. So if I type in Hadoop version, you can see this is version 1.1.0. And you can see that I can go in here and I can look at the name node. I can browse the file system, just like we did when we were looking at the Cloudera distribution with their utilities. In this demonstration, I'm going to show you how to run a MapReduce job for WordCount on a different distribution. This will be on Windows, Azure, Hadoop HD Insight. So I'm in the portal, and to get started, I'm going to click on Samples, and then I'm going to scroll down to WordCount. Now, an interesting aspect of Microsoft's implementation is they've enabled both Java, which is standard, and also JavaScript, which is not as commonly found on their Hadoop installation. So in order for us to work with this, we can just click Deploy to our cluster. And what this will be doing is parsing or word counting this davinci.txt example. And then there's a word count Java file that we'll go over as well. So when we click Deploy, we've got a job runner interface that accepts parameters appropriate to the particular job. So you can see the job name is WordCount, and it's associated to the examples, and I could run another job if I wanted to that I had written with a particular Java or jar file. And then I have two parameters here. I have WordCount, which I'm passing in with plain text, and I could pass this in either from the HDFS file system or from the Azure Blob Storage for ASV protocol here. And if I wanted to, I could validate if I was using one of these other ways of working with it by just clicking here. Then the next thing is the parameter where the source code is coming from, which is davinci.txt, or the source data, if you will, and then where the output is going. Now, because I've run this already once, I have to change the output because, of course, this is immutable, and if I try to run it again, the job will fail. So now you can see that the final command here is listed at the bottom, and I did remove my history. That's why the history is not there. And then I'm going to go ahead and click Execute Job. Now, while this is running, we get highlights from the log, and you'll see I clicked back on the portal, and you might have seen briefly that the job went from in progress to complete. And so now I can take a look at this job by clicking in here, and I can see that the job succeeded. And if I click on the command line, I can now see the logging output, and I can see where the maps and the reduces occurred, and I can see lots of detailed information about the job execution. And if I go back and back again, I can also look at the job history. Now, like I said earlier, I had run this twice, so you can see I have two different outputs from this same input, and you can see ASV, DaVinci all top words, and all top words new. And you can download your job histories. Also, you may remember from the previous demo, I can click on Monitor Cluster, and now I can see the number of mappers, reducers, the queue, jobs, so on and so forth. Now, to drill in and take a look at the Java that was used for this, we can go into the samples and scroll down, and Microsoft has actually listed the Java here, which is pretty standard in terms of word count. They're using for the mapper that they have text and an int writable, object and text coming in, text and int writable going out. And they're using a string tokenizer and a while loop, and basically writing out each word and one. Then in the reducer, it takes a text and an int writable and outputs a text and an int writable, and it simply does a plus equal and sums it up. Then in the main, this sets up the job and sets up what's the mapper class, what's the reducer class. You'll see something called a combiner class that we're going to talk about later in our course as well, and a few other configuration settings. So it is interesting to compare the Java, as I just went over, with the JavaScript. I'm not going to run the JavaScript, but you can see that the JavaScript is really only about a 10-line file. It's much more terse, it's much simpler. And this is one of the things I think is interesting about the Microsoft distribution. So of course, in addition to using this job runner interface, which is available by just running a job, create job. You could, as I showed earlier, remote desktop in and use any of the Hadoop command lines if you were more comfortable there. So in the last two demos, you saw the WordCount MapReduce job run on a different platform in two different languages. So you might be wondering, what is the excitement about Hadoop? Does it do anything other than MapReduce? And we actually are heading towards that, but before we leave looking at MapReduce in different languages, I want to review the JavaScript just again because as we enter into more complex MapReduce, it's important to think functionally and think about breaking our data problems down into the map step and the reduce step. And I actually think the JavaScript is simpler to understand than the Java. So here we go. This is a review of what we just ran in Hadoop on Azure. And again, this is part of the distribution itself. So I just ran a cat from the JavaScript prompt inside of the Hadoop distribution to display the WordCount.js, which is a tip, by the way. You can display from the inside of the JavaScript console any of this sample code, so you don't have to leave the Hadoop environment by just doing a cat command. So you notice you've got the map function and the reduce function, and this is word count. So this is a piece of functionality we're familiar with. So we have a key and a value and a context, and here we're splitting the words based on the pattern, and then we're also changing the case to lowercase just for comparison purposes, and then we're writing the word out and the value 1, so the key and the value. Then passing to the reducer the key, value, and context, and we're just doing a plus equals to add them up. So very, very simple, and we're writing out the key and the sum, so the word and the value. So again, I think this is a very straightforward example, and I think it's a good one for us to keep in our head in terms of parallelization of the initial data process and then aggregation of the intermediate output as we get into some more complex scenarios. So as we start thinking about what other kinds of business problems you might solve with MapReduce, first thing we want to think about is what kind of data sources we might look at. Where do we get the data that we're going to work with, and then what business problems do we want to solve, and then how do we translate these business problems into the MapReduce paradigm. So common scenarios that I'm seeing around the big data implementations are big, huge text files, so log files, which can be semi-structured more commonly, or even unstructured. So machine log files, phone usage log files from service usage like email services, machine-to-machine log files, manufacturing output log files. So lots and lots of log files are a possible input for MapReduce paradigm. Geospatial information as part of behavioral or activity files coming from some of the big telcos. Statistical information, often used in scientific analysis. So I call it piles of numbers, where you're not only producing statistical information or statistical output, but you're cross-referencing from other surveys and sources. So doing a massive aggregation of bundles of statistical output. Of course, the one that most people think of is clickstream, which is advertising and website traversals because of where MapReduce came from. Obviously, Google indexing the web and providing information about the content available on the web. So the idea with this is that most of the information is in a semi-structured state. It is often just text or numbers. And as I said earlier in the course, there are built-in types, and we'll look at the types coming up here shortly in the MapReduce API that are designed to support these types of information. Of course, MapReduce can be used for many, many types of problems, so you can actually write your own custom types as well, but usually text or some type of number or binary input, most common. Now, because MapReduce really can be thought of in a lot of ways as a new aspect of ETL or extract, transform, and load. To me, I think of it as the front of the pipeline because the storage bucket is so much cheaper with HDFS. You're often thinking of this as the first step of processing, or maybe the second step if you've done some pre-processing before loading into the HDFS cluster, but very early on in the data pipeline. Now, that being said, Again, in addition to the type of data, you have to think about where your data is coming from. So you're going to think about whether it's stored in the local file system, if it's going to be in your local HDFS instance, if it's going to be in a private cloud, a public cloud, if you want to go across clouds. I've had this come up with several customers that they're interested in storing, for example, on Amazon, but maybe they want to process on somebody else's cloud, and that currently isn't a really easy scenario. But hopefully as the sort of cloud infrastructure as a whole develops, that will become more and more useful as we really end up with different types of processing as services and we have better interoperability. Currently, most customers who are working with MapReduce in the cloud tend to stay on a single vendor because that seems to be the simplest implementation. So they store their data, their input on that vendor's cloud, usually in some kind of blob or bucket storage. They do the processing via specialized virtual machines with Hadoop installed on them on that vendor's cloud, and then they store the output in that vendor's cloud as well. So this is really, again, a sign of the early ecosystem of the Hadoop and cloud worlds. And I do see this evolving to a level of complexity that will be increasing the possibilities of what we can do in data pipelines. Interestingly, not part of this course, but some vendors, notably Amazon, have actually included in part of their cloud services data pipeline capability, kind of an SSIS, if you're familiar with SQL Server, an ETL type of capability up on their cloud. Now, Amazon's functionality is, I believe, limited to Amazon services, although I haven't explored too deeply beyond that, and it's only been out for about 6 months as of this recording. But it is sort of interesting to think about MapReduce plugging into an ETL pipeline, which could be both on-prem or in cloud or in combination. So think of it as a super, super powerful ETL. So what are the common types of business problems that are addressed by MapReduce being part of the pipeline? And again, I'm going to emphasize part because the real world of MapReduce is not you write a simple word count kind of job and you're done. It's multiple chain jobs very frequently, and also pre-processing and intermediate, sometimes post-processing. So one or more MapReduce jobs are part of a pipeline to produce this output. Now sometimes if you choose to use some of these other libraries, such as Hadoop, for example, which is a machine learning library, and we're actually going to be showing this in the course coming up later on, it will generate for you multiple MapReduce jobs. But again, very important to understand from a low level what each of these jobs is actually doing, because you're going to be responsible, of course, for running these jobs efficiently in whatever environment you're in. So what are some of these common data jobs? Well, text mining, retrieving out subsets of information out of massive quantities of text is clearly and probably pretty easy to understand in terms of the mapping and reducing. So split the text across the mappers, look for certain patterns, and then count up the occurrences of certain patterns. So word count or word word adjacency, phrase adjacency based on regex or some kind of pattern matching. Very, very common usage of this. Index building, that's the original use, of course, coming out of Google. Graphs, the connections between various data nodes, that's for website traversal, following the click streams through different websites. Interestingly, more and more applications are starting to consider the possibility of instrumenting not just those public websites. This is a kind of a front of the technology technique, but Google has exposed, for example, some APIs around analytics that allows the capture of customized data points throughout applications. And I've actually done some work with this and then taken the large amounts of data that were generated and used MapReduce to process some of that data to improve basically the usability of the application through data feedback. Patterns, filtering, prediction, and risk analysis. Risk analysis is a huge area for MapReduce. One of the biggest things that I see in the actual real-world implementation is the hotbeds are very much around financial services, healthcare. New York is a big center for MapReduce. London, financial center, another case. There are certainly different verticals or industries that use MapReduce, but financial and risk prediction around, for example, insurance and other types of financial instruments have been using these kind of technologies actually for quite a long time and are just expanding their usage as the availability becomes more broad, more people are trained to write MapReduce, and the cloud makes storage even cheaper. So in the demo coming up, I'm going to run on Hadoop on Azure again, HD Insight. I'm going to run a couple of jobs that are not word count. I particularly wanted to do this because the leap from word count to real world MapReduce is pretty large, and I wanted to provide a bridge in this course. Now, what I'm going to do is I'm going to go ahead and run this so you can get an example of what they look like. And you can see the gray sort has 3 separate chain jobs, the TerraGen, TerraSort, and TerraValidate inside of it. The Pi estimator just spawns a whole bunch of maps, which is kind of interesting to look at. I would also recommend that if you get onto this beta, you review the Java MapReduce code in the samples to see the actual implementation of this. So you can see the mapper and the reducer. I think at this point it's probably just interesting to review the Java and go through the jobs so that you can start to understand the different types of MapReduce jobs that you can run using this paradigm. In this demonstration, we're going to take a look at some other types of MapReduce jobs. A really great way to get started with this is if you do have access to the HD Insight distribution, to just take a look at some of Microsoft's samples. They're pretty well written, and they help us to understand some other types of MapReduce jobs as we're learning more about the MapReduce algorithm. So if you'll see inside of the samples, we've got 4 other types of samples in addition to the word count that we've already seen in the previous demonstration and discussion. So those are the gray sort, the Pi estimator, C# streaming, and scoop import export. Now this is a little bit misleading because of these 4, only 2 of them have MapReduce jobs that perform different types of activities than word count. C# streaming shows how to use C# to write the mapper and reducer for word count, passing it in and out via standard in and standard out, a kind of piping. And I would recommend that you take a look at that if you are a .NET developer, but because it's a little bit redundant, I'm not going to do that here. Scoop, you may remember from earlier discussion, is a utility that allows you to import or export data. And I'll just click on it so you can see what it looks like here. And you can see that this requires that we have to RDP to the head node of our cluster, and then we just basically run some jobs to import from Windows Azure SQL or SQL Azure into HDFS or back out. So this isn't really a job per se, it's data transfer. So that being said, let's go ahead and look at these other 2 types of samples that we can run here. So the first one is the 10 GB gray sort. So this is another type of a benchmarking MapReduce job, as it says here. It's often used to benchmark performance in a Hadoop cluster. There are 3 jobs to run: TerraGen, TerraSort, and TerraValidate. So if we click in here, it's going to show us how to work with this. So TerraGen is MapReduce to generate the data. TerraSort samples the input data and uses MapReduce to sort the data to a total order. And TerraValidate is MapReduce that validates that the output is sorted. Here we get into a little more interesting scenario, more like an ETL scenario where you have multiple MapReduce jobs that are in effect chained to do multiple types of processing. So if we go ahead and we click on deploy to our cluster, what we're going to see is here is our job with our jar file, and then here is the TerraGen first, where we are passing in the other parameters, and here's our output. So if we go ahead and click execute job, now you can see, as with our word count, if I navigate back to the portal, the front of the portal, our gray sort is still in progress. And now you can see that the job has completed. So if I click into the job, I can take a look at the history just like we did with word count. And I can see that unlike word count where we had very few mappers, we have lots and lots of mappers running. Now if I go to the next sample, this is a Pi estimator. So what does this thing do? This will submit a Hadoop jar job and run a distributed pi estimator with 16 maps. Each map will compute 10 million samples. Of course, running it is going to be simple. Just click Deploy to Cluster, and then we go ahead and execute it. And we're familiar with this here. This will run this, so I'll pause, then we'll show you the output. And you can see now I've clicked on the console and the pi estimator job is complete. And if I go into the output, we get job succeeded. And this output log looks a little bit different than the other ones in that we have the input for the various maps, and then we can see the output here, the estimated value of pi. And here's the detailed run here where we have the maps running. And then when the maps are done, then the reduces run. Of course, we can also look at the cluster monitoring now, which will look a little bit different since we've run quite a few more jobs in the various demos. And of course, we've only run jobs through the job runner. You also could run jobs through the interactive console or the remote desktop. So as we saw in the last demo, there are different types of activities that MapReduce can do on data. It doesn't just have to be a pattern match and a retrieval and an aggregation. There can be multiple passes, as we saw in the gray sort, or multiple mappers, as we saw in the pi calculation. So as we learned earlier in the course that there are several methods to execute MapReduce jobs, and I've been certainly demonstrating them as well in the demos. There are a lot of different methods available to you to write MapReduce jobs, and one of the areas that you'll have to consider as you become proficient in this technology is which of the methods do you want to focus on, because you obviously can't know all of them. So it is perfectly acceptable to say that you're not interested in learning any of these low-level MapReduce jobs, and there are in fact many working professionals who focus on using the higher abstraction libraries such as HIVE and PIG, so on and so forth, and they are able to do certain types of problems very successfully. Like I have said earlier, I think it is important to have a basic understanding of how MapReduce works, even if you're implementing relatively simple jobs. Now, in other business situations, it would be more appropriate for you to work in a lower level language such as Java, or you can work in other types of languages using other methods. Now, the API itself, the MapReduce API, is written to be directly supported through Java. And as a point of information, there are two separate versions of the API. I'm using MapReduce 2.0, which is released last year, I believe, and has some slight improvements in terms of the MapReduce itself. There's some other significant improvements in terms of the availability, the configurability, but in terms of the simplest possible jobs, it's really just a change between MapRed and MapReduce and a few things in the job configuration. If you have MapReduce 1.0, you probably can still read it and work with it, even looking at the samples in this class. If you want to use a different programming language to write the logic in your mapper and or your reducer, you have a couple of different other methods to write those methods. And the methods are using streaming, where you work with standard in and standard out. And then you can use basically almost any language to write the actual logic. And we'll be showing an example coming up in C# as well as Python. You also, if you prefer to write in C++, can use pipes. Again, you want to use the language obviously you're proficient in and the best language for the job. And of course, we've already talked about the abstraction libraries. I'm going to show you a local installation on Windows using the isotope or the ported Hadoop bits and running a job or two in C#. So in the demo, it will be on Windows 8 with C# for the MapReduce and PowerShell to execute the MapReduce job. In this demonstration, I'm going to show you how to work with a local instance of Hadoop running on Windows. What I've done is I've set this up per the instructions in the lecture, and now you can see that I've accessed the local instance via localhost:8085, and I brought up a command prompt here where I've executed PowerShell command to run some data, so download some data, so I have some data to work with, running the getting started. So I'm going to be working back and forth between the command prompt and the local cluster here. So I'm going to go ahead and click on local cluster, and I'm going to click into getting started, and you can see this looks much like the interface for the Azure based version. This is running on my local machine. I'm actually running it on a MacBook Air. I'm running it on a virtual machine running Windows 8. So I'm going to go ahead and click Hello World, and I have loaded some of the data here. So what I did is I just ran that PowerShell command there to load the data, download it from the web. So now I'm going to go back to where I was, and I'm going to start working with MapReduce. So the first thing here is I'm going to run this PowerShell command that's going to run some Java MapReduce jobs against the sample data. And here's the core Java that is going to show what MapReduce is actually being run. So I'm going to copy this, and I'm going to paste this into the interface for running PowerShell. Again, kind of interesting for those of us coming out of the Windows world. The only time I've ever seen MapReduce run with PowerShell. Normally it's going to be run from the job tracker from Java, or from Pig or some other type of a shell. So continuing on, I actually was waiting for the jobs to finish, and they didn't finish, so I went ahead and ran the C# job as well. And I think probably the more interesting thing in this implementation, particularly because I have a lot of .NET developers here, is rather than to wait for these jobs to finish, is to actually look at them. So I pulled this C# job in particular into Visual Studio 2012, and I wanted to show you the sample code and talk about how this job chaining actually was intended to work. First of all, before I go into this, and there's 3 different jobs here. You can see average time job, average time taken, errors by page, error job, total hits, and total hits job. So we have like 3 jobs chaining. How the PowerShell calls the job was also interesting. So I opened up the PowerShell sample here, and you can see that we've got a bunch of variables, and then we have we're running, depending it's whether it's Java, Pig, Hive, so on and so forth. So pretty nicely written samples. So we're setting the Hadoop home variable, which you always need to run a job, and then we are running call Hadoop, and that is just calling for the HDFS. It's removing a directory, making a directory, working with the sample data, and manipulating HDFS. You can see call Hadoop, here's HDFS, remove directory, and then run a jar. So this is a job runner, if you will, through PowerShell, which is pretty interesting. So this sample is part of the local sample. Now let's switch over to the C# streaming, and you'll remember from the lecture that this uses the standard in, standard out most generally. So let's go ahead and take a look first at the total hits jobs C#. This is using the Hadoop MapReduce library that we talked about when we configure for development. And inside of here you can see that we are just setting up the environmental variables, and then PowerShell is actually running the job. And this is extending Hadoop job. So what job it's running is the total hits for page job. So let me bring that one up. And that's where you're going to have your map and reduce code in C#. So here's your map, and you can see inside of here what we're doing is we're taking a string, and we are just splitting it to emit the values out from the maps, and then the reduce is doing the aggregation here. So we're doing a sum in this particular reduce. So we're counting the hits per page. I didn't actually look in the order of these, so I would think that it's hits and then probably errors and then average time. So let's look at the error job for the pattern. Same thing, we're just getting the variables, and then the errors per page. We've got a map here. We're doing a regex pattern, and then we're just looking for records with values, so getting rid of the exceptions, basically filtering them out in the map. And then in the reduce, what we're doing again is we're just summing up. So it's just taking the errors out. Now this is an interesting pattern in that we counted the hits in one MapReduce job, and then we filtered out the errors in a separate. This is that thinking in a sort of a functional way that I talked about earlier when designing MapReduce jobs. Rather than combining this is actually separated out for efficiency across a cluster. And then the very last part here is the average time taken. So again, nothing new here. This is just to pass the variables in. And then the MapReduce portion of this is as follows. Let me just hide this so you guys can see it. So you've got the map, and what this is doing is averaging. So taking in the values from the secondary job, which was the error job, and then in the reduce, we're just performing the average here. So this is actually a pretty good example of chaining jobs, and of course it's most familiar probably to much of the audience written in C#. So I would encourage you in your exploration to follow the steps that I talked about in the setup to get a local instance of Hadoop or Isotope on Windows. In the next section of the course, I'm going to jump off of the Microsoft implementation of Hadoop and move to another distribution of Hadoop, and this one will be a cloud-based distribution as well, and in fact the leading cloud-based distribution. Amazon MapReduce is a production service and has been in production for several years, and is in fact, based on the statistical information I was able to research, the leading provider of on-demand MapReduce. So it's quite critical if you are going to run MapReduce jobs in the cloud that you have a basic understanding of Amazon's implementation. And the word count logic will be written in Python, just because it's sort of fun to see the different variations in different languages. Now you can work with the Amazon services for MapReduce just like you work with any Amazon services. The easiest way is through their GUI to get started. They have command line tools you can download, and they also have SDKs, including a .NET SDK if you want to access programmatically. I know when I took a class in this, and when I was learning, they had Python utilities that I was running from my Mac locally to spin up Amazon MapReduce clusters. Now, one thing I will caution you on is there is with Amazon a free tier the first year that you sign up as a customer, and I'm not actually sure if MapReduce is included in the free tier. I think it's not actually. But in any case, you want to be really careful that you incur only the charges that you are expecting, because this is not a beta, this is a production level service. So if you're trying out something really small, I've never had more than like $5 or $10 of charges, but there will be charges associated with even trial usage of this. In general, you're running an EC2 instance with Hadoop installed on it with some distribution, and just like any other EC2 instance, you're going to be charged based on the compute power, and you have a minimum charge of 1 hour, because that's the way Amazon works for on-demand instances. Like other EC2 instances, you can use spot instances, and you can also use reserved instances to save money if you're doing this on an ongoing basis, which is actually quite important with Amazon in general. So getting back to AWS MapReduce, you can select, as it's showing here in the screenshot, first you're going to upload your data to the Amazon S3 bucket, so that's going to be your source data, and then you can select the particular distribution of Hadoop that you're interested in. They have both the sort of plain vanilla Apache distribution, and they also have 2 versions of MapR, which is a vendor that provides tools and some other utilities with their distribution. And then you will specify your MapReduce file, which you can call from various methods. And like I said, we're going to use the pig language here to show you how to do that. And then you will get your results back out into a new Amazon S3 bucket. So speaking of pig, I've mentioned this a couple times in the course, but we'll take just a minute to talk a bit more about it. So pig is a library and a language, kind of like HIVE, that is an abstraction layer over a MapReduce. And it is contrasted to HIVE in that HIVE is an exploratory SQL-like language that really was designed to take a quick look at subsets of data stored in HDFS, relatively quick because it's of course not interactive. Pig has more functionality related to pure ETL, and as I was talking about a couple slides ago, in many ways MapReduce jobs are really becoming part of the big data pipeline. So Pig was developed at Yahoo, again, because it was just simpler to have an abstraction for common patterns of ETL rather than write all the Java or whichever language for the MapReduce code. So you have the Pig runtime, the Pig language, and this will, like HIVE, it'll generate MapReduce jobs. So again, if this is a business case for you, I recommend that when you finish watching this video that you take a look at some of the resources on the Pig language. It is marked by keywords such as load a particular file, and then you do some sort of process, and I just listed some of them here, like filter, join, group by, for each, generate, or count, and then you can dump the result to a screen for testing or just checking the output. And then when you're satisfied with it, you can replace the dump command with a store command to store the output to a new file, and that'll generate your MapReduce job. So again, looking at these different abstraction languages is part of working with Hadoop MapReduce. So I encourage you to take some time to take a look at this if this is an interesting use case for your particular business needs. Also, I mentioned that when we run the AWS sample, we are going to use Python. So I've included this in the source code. And again, I'm assuming that most of the people watching this are not familiar with Python. So I've just made a little screenshot here in my editor of choice, which is Sublime. And I wanted to emphasize that if you're not familiar with Python, one of the things that is to be aware of is that it is white space sensitive. So you can see there's the main, and we're using here the pattern of the standard in, standard out, which I also wanted to show you an example of. So I've got this in the course sample code, so Python's kind of fun, so you can try it out. Again, figure out which language is going to work best for you. This going into the world of Hadoop and MapReduce has caused me to start to learn some new programming languages, and maybe you will do the same. So in the demo, we are going to spin up an AWS Hadoop cluster, and we're going to use the wizard to do that. They call it a job flow. What's happening under the hood is I will be picking, I believe, a 4-node cluster, so it will be spinning up 4 EC2 virtual machines with a Hadoop distribution. I'm going to select the MapR distribution, and then you can see that I have various job flows that I can work with here. I can run my own, obviously, or I can run a sample. And I'm picking one of the samples, but you can see that I have the ability to work with HIVE, so that's pre-installed on these EC2 images. I can do streaming, so that's with the standard in, standard out. I can use a custom jar, so a Java file, or the last one, I can use a Pig script. In this demonstration, I'm going to show you how to use Amazon Web Services MapReduce to run a Hadoop MapReduce job on the Amazon cloud. So in order to get started, I'm at the Amazon Web Services website, and I'm going to access my console. And you would need already to have an Amazon account to do this, so I'll sign in. I do caution you that you can incur quite a lot of charges here because there is not a free tier, or if there is, it's really small. So you want to be careful in trying out this feature, and if you're really just testing it, use a very small amount of data. So you'll see in the console here you've got Elastic MapReduce Managed Hadoop Framework. I'm going to go ahead and bring that up. And it gives me the option to create a job flow. So to create a job flow, I can click on this button right here, and it'll take me through a wizard. And here it's telling me what's going to happen. Upload an application and data to an Amazon S3 bucket using the client tools. Specify the data inputs, outputs, processing of the application, the number of EC2 customized instances with a Hadoop distribution on them, and launch the job flow. When the job flow is done, then you can pick up the results from the output bucket. Now you can run jobs through this GUI. Of course, Amazon also has command line tools, and they have various SDKs, so you can actually spin up a MapReduce job flow. I'm going to click Create a New Job Flow. So here I'm going to call this Lynn Pluralsight. And I first select my distribution of Hadoop. So I have a couple different options. I can use the Amazon distribution, or I can use a MapR distribution that has enhanced features. So I'm going to just select the Amazon distribution, And here it tells me that I can run Hive, custom jar, streaming, pig, or HBase jobs. Now I can run my own application and upload my own files, but for the purposes of this demo, I'm just going to use one of their samples. So I'm going to run a sample application, and they have samples of different types. So the one that I'm going to do is I'm going to run the word count that's streaming. And here it tells me it's a Python application that counts occurrences of each word in provided documents. And inside of here, I'm going to specify my parameters. So I'm going to have an input bucket, then I'm going to have an output location, which is my output bucket, and then I'm going to have my word splitter Python, which comes in their samples, and then the reducer is going to aggregate, and then I can have extra arguments. I'm going to pause the video while I go ahead and look up my output bucket because it has to exist for this to work properly. So I've configured the output location to an existing bucket, and then it's going to create these output folders as well as the output when the job runs. So I'm going to go ahead and click continue. And now I'm going to specify. I specify my instance type, so small all the way up to high, very different in prices. And notice I have the opportunity to request a spot instance, very important in keeping costs low. This is basically instance size that will only spin up when there are instances that are not being used. It's kind of like a price line, but for compute. So it may not spin up if there are not instances available. This is a run at a much lower price. So then I have core instance groups, and I'm going to start with 2 instances again. Same type of pricing and configuration options, and task instance groups. So I can run Hadoop tasks. Of course, I'm not having persistent data. That's going through to S3. And again, in this case, very small job. I'm just running with the minimum possible configuration rules. Notice it says for more than 20 instances, then I would have to request specially from Amazon. And I'm going to click continue. So now I can proceed without a key pair if I don't need to SSH into the master node. If I just want the job to run, I can specify this runs on a virtual private cloud or some type of address location, and then I can log if I wish to out to S3. I can debug if I wish to. I can keep this job alive, which means I could reuse it. I could add termination protection, and I could make this visible to all authorized IAM users. When I'm trying this out, I'm just going to take the minimum options, but I wanted to review all the options that are available to you. I'm going to click continue, and notice I have the option to associate bootstrap actions with this particular job flow, and if I wanted to do that, I would just click here and configure them. The types of things I could configure: Hadoop, daemons, install, run if, custom actions, so on and so forth, but I'm not going to do any of that as well. And then I'm going to click continue, and then I'm going to create a job flow. Now I'm doing a refresh to see that my job flow is started. And again, I'll pause the video and I'll come back to it as this job is progressing and then completes. Okay, updating the job, you can see now that it's running, and I have 1 minute of elapsed time, and I have 3 normalized instance hours because I have 3 instances. And again, returning to our job, you can see that we have a elapsed time of 4 minutes. And I checked in my S3 bucket, which was created word count here. And here's the output. And I got the success output, which is what I was looking for. And you can see there's my part 1 of my word count. So a couple other points of information. The programming language that was used here was Python for the particular execution of the job flow, and that sample can be downloaded from the Amazon samples. So this was, there's completed. So it took 6 minutes, and this was an example of running a MapReduce job up on the Amazon cloud. Since we've just seen the demo of AWS MapReduce, and I did mention the data pipeline, I thought I would stick a slide in here to show you what it looks like. This is a screenshot from the AWS console, and what I've done here is I've created the simplest possible data pipeline using the template. And you can see, as I said, if you're familiar with other ETL tools such as SQL Server SSIS, this is really kind of an interesting usage of a MapReduce job, in this case, in the cloud, in Amazon's cloud. And you can see there we have a visual designer where we have input and output, and then we have a processing activity, just real simple flow, in this case a single activity, and that is a Hadoop activity that is actually running a HIVE command. And you can see over to the right I've highlighted which resources are being used by this transform activity, and this is an EMR cluster, which is a MapReduce cluster that can be spun up on demand as part of the execution of this schedulable pipeline. So again, this is a service area to really keep your eye on. Very, very interesting in terms of running data pipelines in the cloud.